Your phone just powered on in a new city. Within seconds, it is on the network, apps load, and calls work. That seamless moment hides a hard gate. Before any data flows, the 5G core must authenticate the device and register it. If either step fails, you get no service, just a quiet rejection. This lecture walks one specific failure path from the 5G registration story. A device sends a registration request. Authentication starts and even looks successful. Then the network goes looking for the subscriber's profile and finds nothing. The result is a registration reject. Why should you care? Because in real networks, authentication success is not the whole game. Subscriber data has to exist, be reachable, and match what the access and mobility function expects. Missing data is as fatal as a wrong password. We will stay close to the actual message names and functions. SUCI, AMF, AUSF, UDM, SIDF, and a very specific HTTP 404. Data underscore not found. By the end, you will be able to narrate the full path out loud and explain exactly where the reject is decided. Before we chase messages, meet the cast, 5 roles you will see again and again. The UE is the user equipment, your phone, modem, or any 5G device trying to attach. It does not talk to every core function directly. It talks through the radio into the AMF, the Access and Mobility Management Function. Think of the AMF as the front desk manager for mobility and registration. It decides whether this device is allowed on, keeps track of where it is, and coordinates the rest of the paperwork. Authentication itself is not the AMF's specialty. That job belongs to the AUSF, the Authentication Server Function. The AUSF is the security desk. It runs the authentication procedures and decides whether the credentials check out. Behind the security desk sits the UDM, Unified Data Management. This is the subscriber database brain, permanent identities, authentication vectors, and the subscription profile that says what services this user is allowed to use. Sometimes the device does not send its permanent identity in the clear. It sends a concealed version. Deconcealing that identity is the job of the SIDF, the Subscription Identifier Deconcealing Function, often sitting with the UDM. Hold those 5 names: UE, AMF, AUSF, UDM, SIDF. The rest of the lecture is just how they pass messages when something goes wrong. The story opens with a registration request from the UE. Inside that request sits a critical field, the SUCI, Subscription Concealed Identifier. Plain English, it is a privacy protected version of who the subscriber is. Earlier generations often put a permanent identity on the air in ways that could be tracked. In 5G, the device can hide that permanent identity behind cryptography, so eavesdroppers on the radio path cannot casually read it. So picture a hotel guest who will not shout their passport number in the lobby. They hand the front desk an opaque envelope the hotel's back office can open. The envelope is the SUCI. The passport number inside, once opened later, is the SUPI, the Subscription Permanent Identifier. The AMF receives the registration request. It now knows a device wants in, and it has a concealed identity to work with. It does not yet have a full subscription profile. It does not yet know whether this subscriber even exists in the home data store. Authentication and data lookup still have to run. Here is the part that matters. Everything that follows is triggered by this one request carrying SUCI. No request, no procedure. Wrong or unknown identity data later, and registration dies, even if the crypto handshake looked fine. The AMF does not authenticate alone. It calls the security desk. It sends a service operation with a precise name, NOSF underscore UE authentication underscore authenticate request. Strip the jargon and it means AMF asking AUSF, please authenticate this UE. Here is what I received. In a healthy path, the AUSF will drive challenge response style authentication, involving the UDM for authentication data, and eventually return a result the AMF can trust. Our source scenario starts that chain the same way. The registration request arrived with SUCI. So the AMF packages that context into the authenticate request toward the AUSF. Why this split? Separation of concerns. The AMF is busy with registration state, mobility, and connection management. The AUSF specializes in authentication protocols and keys. If you collapsed everything into one box, you would couple mobility failures to security failures and make roaming and multi vendor networks much harder. So, at this beat in the story, the baton has moved UE to AMF with the registration request, then AMF to AUSF with NOSF underscore UE authentication underscore authenticate request. Authentication is officially underway. The AUSF cannot invent authentication data. It must fetch what the home subscriber store knows. So the AUSF sends nudem underscore UE authentication get request to the UDM. In plain words, give me the authentication material for this subscriber context. If the identity on the table is still ASUCI concealed, the UDM may involve the SIDF. The SIDF's job is narrow and vital. Turn SUCI into SUPI. Open the opaque envelope. Recover the permanent subscription identifier so the database can actually find the right record. Analogy. The security desk received a locker key code written in a cipher. The deconcealing function is the codebook. Without SUPI, the UDM is searching a filing cabinet with a blank label. Once SUPI is known, the UDM can return authentication-related data the AUSF needs. In the scenario we are studying, this part of the path is presumed to succeed. That is important. The failure we care about is not a failed AKA challenge. It is what happens after authentication when the AMF asks for a different slice of subscriber data. Remember the sequence: authenticate request into AUSF, get request into UDM, optional SIDF deconceal of SUCI to SUPI, authentication material back. So far, so good. One deployment detail changes how you picture the boxes on a whiteboard. In this setup, the AUSF and the UDM are co-located, or internal, to what the source calls the registers network. They may be separate logical functions, but they live in the same trust and routing neighborhood. Messages between them are not crossing half the internet. They are short, internal hops. Why mention that? Because students sometimes imagine every 5G function as a distant cloud microservice with huge latency. Sometimes, yes. Here, authentication server and unified data management sit together. That can simplify certificate trust, reduce round trips, and make certain failure modes look local when you debug. It does not erase the logical steps. You still reason in service operations. NowZef toward AUSF, NUDEM toward UDM. Co-location is a placement choice, not a license to skip the procedure. And again, authentication is assumed to succeed at this stage. The device proved it possesses the right credentials. The permanent identity was resolved. The AMF is ready for the next mandatory ingredient of registration: the subscriber profile data it needs to finish accepting the UE. Authentication answered, "Who are you?" and "Do your keys check out?" Registration still needs, "What is this subscriber allowed to do? And how should we steer their sessions?" So the AMF turns back to the UDM with a different call: nudem underscore subscriber data management get request. The source names the datasets of interest: am.smf underscore sel, sms underscore sub, and uec underscore smsf. Let us unpack those without drowning. SMF underscore SEL relates to how the network selects session management functions. Basically, which user plane and session control path this subscriber should use. SMS underscore sub speaks to SMS subscription. Is short message service part of what they bought? UEC underscore SMSF relates to UE configuration for the SMSF, the function involved in SMS in the 5G core. You do not need to memorize every abbreviation expansion to see the pattern. The AMF is fetching access underscore and mobility relevant subscription slices so it can complete registration cleanly. Steering, messaging flags, and related configuration. Real world picture. You showed a valid employee badge at the building door. That was authentication. Now HR must confirm your role, floor access, and mailing list before the badge is activated for the elevators. No HR record, no activation, even with a perfect badge crypto chip. That get is the hinge of our failure story. The UDM answers the subscriber data GET with an error. HTTP status code 404, data underscore not found. Read that carefully. 404 is not wrong password. It is not try authentication again. It means the resource the AMF asked for, this subscriber's data set, is not there. From the AMF's point of view, the cupboard is bare. How can authentication succeed and data still be missing? Several operational realities create exactly that split. The identity might deconceal to a SUPI that has authentication vectors provisioned, while the access and mobility profile never got loaded. A migration script might have half created the subscriber. A test sim might exist in the auth database, but not in the full UDM profile store. Or the GET might be asking for specific data keys that were never written for this user. Data underscore not found is brutally clear. The UDM looked and the data was not found. No profile slice for am.smf edicel, SMS sub, UEC SMSF as requested, or no subscriber record that can satisfy that GET. This is the moment the happy path dies. Not at the radio, not at the AUSF challenge, at the subscriber data management read. The AMF receives 404 data underscore not underscore found and makes a hard decision. It cannot complete a valid registration without that subscriber data, so it rejects the UE's registration request. The source names the outcome simply, registration reject error. The device that started with a registration request carrying SUCI does not get a registration accept. It gets told no. From the user's seat, this can look like no service, emergency calls only, or a stuck attaching icon, depending on the device and any fallback. From the network engineer's seat, the logs should show the chain. Registration in, authenticate exchange, subscriber data get, 404, reject out. Why must the AMF reject rather than accept with empty defaults? Because those data bits drive real behavior, session management function selection, SMS-related subscription, configuration toward SMSF. Accepting without them would create a half-registered UE with undefined policy. That is worse than a clean reject. You would get subtle user plane failures, wrong SMF anchoring, or messaging broken in ways that are harder to debug than a clear registration failure. So the control decision is conservative and correct. No subscriber data, no registration. Let us run the entire path once, start to finish, as one continuous story. Keep the failure branch in view. Step 1, the UE sends a registration request containing SUCI, the concealed subscription identifier. Step 2, the AMF sends nowcef underscore UE authentication underscore authenticate request to the AUSF. Step 3, the AUSF sends nudem underscore UE authentication get request to the UDM. If needed, SIDF deconceals SUCI into SUPI. Authentication data is obtained. In our scenario, authentication succeeds. AUSF and UDM are co-located inside the register's network, so those hops are internal. Step 4. After authentication, the AMF still needs subscription material. It sends nudem subscriber data management get for am.smf-sel. SMS subscriber denim-UEC-SMSF. Step 5, the UDM returns HTTP 404 data underscore not underscore found. The profile pieces are missing. Step 6, the AMF issues a registration reject toward the UE. Procedure ends without a registered mobility context. If you only remember one sentence, make it this. Authentication can pass and registration can still fail when subscriber data is not found. That single distinction separates crypto success from service success.